Welcome to Mr. V Teaching Math. Let's talk about scientific notation. Mathematicians are lazy. They're always looking for shortcuts. I'd like to show you one shortcut that they use rather often, especially in science, which is why it's called scientific notation. Many times in science, scientists will end up with extremely large or extremely small numbers. Extremely large numbers if they're examining planets and galaxies and distances in outer space. Extremely small numbers if they're measuring, the size of the nucleus of a cell, for instance. But rather than writing out these gigantic numbers, which can be even bigger than this one, they use what's called scientific notation. This, in short form, would be written like this. 3.45 times 10 to the power of 11. This and this are the same. But how do you get that? How do you go from here to here and back again? Allow me to demonstrate. Here is the way scientific notation is done. Go and place a decimal behind the first non-zero number in your question. Then you're going to count how many spaces you just moved the decimal. Remember the invisible decimal that used to be over here? It just moved over here. How far did that invisible decimal that was sitting here earlier move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I just moved the decimal 11 spaces. It's important to keep that in mind. .45 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the same as that. It's 3.45 times this really big number. What's an easier way of writing this? Well, this is 10 times 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 10, like this. 3.45 times 10 times 10 times 10 times 10, 10, 10, 7, 8, 9, 10. Oh, running out of room. There's 11 of these. But wait a minute. When we're doing this, there's a shorter way of writing that. 3.45 times 10 to the power of 11. This is 10 times itself 11 times, which would give me this, which would give me the original number. Let me do another example to show you how it's done. Another really large number. I want to turn this into scientific notation. Step 1, I'm going to move the decimal behind the first non-zero number. Step 2, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved the decimal 10 spaces. It's going to be 6.7 times 10 to the power of 10. I moved the decimal 10 spaces. I know that that's going to be to the power of 10. Another number. 6, 8. A little bit smaller. Again, I'm going to move the decimal. 1, 2, 3, 4, 5, 6. It's going to end up there. I just moved it 6 spaces. 6.8 times 10 to the power of 6, because I moved it 6 spaces. Now you can do the same thing with very small numbers. Again, we're going to move the decimal and put it behind the first non-zero number. Not just sticking another number to make sure it's clear. I'm going to put it here, behind the first non-zero number. I'm going to count the number of spaces I moved it. 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 spaces. It's going to be 8.7 times 10 to the power of, and this is different, Because now we're dealing with a fraction. And if you remember earlier, we learned that negative exponents are a way of expressing fractions and decimals. So it's negative, whoops, I forgot. 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. Again, another example. A little bit shorter. I want to turn this into scientific notation. 1, 2, 3. I'm going to move the decimal there, and I know that it's going to move 3 spaces. It's behind the first non-zero number. That will end up with 4. Decimal 2 times 10 to the power of negative 3, because the negative, I'm dealing with a decimal or a fraction, I'll have a negative exponent. That's how to turn large numbers into scientific notation.